Hi everyone. Okay, so in this video we're just going to quickly, very quickly look at the tangent function. It's 5.3 and it's still outcome T4. So what the tangent function is, it's, well, if you recall that tan theta is sine theta over cos theta, and where sine represents the y values and cos represents the x values, we're going to see that tan theta is the slope of the line through the point P0. So you see here how we've got our rise is going to be the sine value and our run is going to be the cos value. So when you put them together as the slope, you end up with tan. Okay, so that's where tan theta comes from. Now, if we look at the coordinates, so if we take x and we plug it in here, and we end up getting these y values as our outputs for tan x. At pi by 2, we notice we get an undefined. 3 pi by 2, we get an undefined, and then every pi thereafter, we get an undefined in either direction. We've got some zeros here, so we end up with a 0 at x equals 0, a 0 at pi, and a 0 at 2 pi, so we end up with zeros at every pi thereafter as well. So I've done a couple of things to this graph already. I've changed the scale here so that it goes -2, 1, 0, 1, 2. And then I've drawn these asymptotes, these dotted lines here, 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 and here. And these are all happening at my pi by 2 and intervals. Okay, so every pi thereafter. So this is, this is negative pi by 2 over here. This is pi by 2. This is 3 pi by 2, and so on. Okay. Now we've got a couple of points here. So see, if I just start from, if I start with this one here, if I look at 3 pi by 4, I've got -1. So that's right around here. And at pi, I've got 0. And at 5 pi by 4, I end up with 1. Those are kind of the three main points that we want to graph for the tan function. And then we just connect them together with a slope. Now you've got an asymptote here, so it's going towards, and then there's a nice gentle slope, and then it starts going in the other direction when it gets down below. So make sure you've got the arrowheads on either sides, and there you go. So I'm just going to draw this one in again, and this one kind of goes off the graph for me here, but that's okay. You kind of get the idea of what's happening with the tan function. So it repeats itself. The pattern repeats every interval. So you see here between the negative pi and pi by 2, the pi by 2 and the 3 pi by 2, and so on. So the pattern repeats itself. So just to look at the properties of tan theta, the domain for it, x is an element of the reals except for at every pi by 2 plus n pi. So every pi by 2 and then plus constant rate of pi. It's just not coming out right. You have an asymptote. So these are your asymptotes right here. Okay, so the range is infinity, negative to positive. Okay, that's because it's going straight up and down and it just keeps going. That's where these, so if I show you, that's referring to like these guys going all the way up and all the way down. And I'm going to have zeros at every pi. So every n pi, I have a 0. My y-intercept is at y equals 0. Periods are pi, and the equation of the asymptotes is right up exactly the same here. So it's x equals pi by 2 plus n pi, where n is an element of the integer set. Okay. All right. So that's just a quick one on tan, just to give you the properties. Here's the homework. Make sure you do your homework. See you soon. Oh yeah, and there's also some questions in the notes that I want you to try. So this is the homework for you to try on your own. We'll correct these in class. All right, thanks for coming out.